Okay, so let's look at the set of directions. They're asking us to solve and to write the solution in interval notation. So let's look at number 1. Do you notice in number 1, they gave me 2 inequalities, and it's joined by the conjunction and. So, first things first, they're asking us to solve, correct? Well, I know how to solve inequalities. Agreed? So let's look at this first one over here. X plus 1 greater than or equal to 7. Let's solve that. How are you going to solve this first one? Minus the 1 from both sides, so we end up with x greater than or equal to 6. Agreed? Okay, let's look at the second one over here. We're solving, so we move the 1 to the other side. So we have 3x is greater than or equal to 6. Divide both sides by positive 3. Does that flip my inequality sign? Good, it doesn't. Good job. So x is greater than or equal to 2. Yes? Okay, so I actually solved the 2 inequalities. Check. Now, since they want me to write the solution in interval notation, if you remember a previous lecture, to write the solutions in interval notation, you must have a graph, or not must, but my recommendation, it is best to write interval notation from a graph. So if you need to refresh yourself, go to a previous lecture to refresh yourself. So I'm going to graph. And there's 2 numbers I care about on this number line. I care about the 2 and I care about the 6. Are you with me? Okay. By the way, it's good to have colored pens, pencils, crayons at this point in time. So I recommend go snagging some from your little brother or sister, or even a couple of different colored highlighters. Here was my first solution. X is greater than or equal to 6. So that means I'm looking for numbers that are to which side of the 6? Good, to the right of it. So I want all these numbers to the right of 6, and it goes all the way out to infinity, doesn't it? What are you going to put on the 6? A parenthesis or a bracket? Good, a bracket, because that means equal to, doesn't it? Now, let's look at the other solution. The other solution said x is greater than or equal to 2. So, which side of the 2? Good, over to the right, so I want all these numbers over here all the way out to infinity. And on the 2, also a bracket because it said equal to. Now, here's the deal. I solved the first inequality, I solved the second inequality, I even graphed, and I'm ready to write the interval notation. But there's one word I haven't taken care of yet. I haven't looked at the word and. What's the word and mean? It means intersection. It means overlap. It means what do they have in common? So if I look at my shadings, what do they have in common? Where do they overlap each other? Where is the intersection between these 2 shadings? Excellent. The overlap happens starting at the 6 and going out to infinity. Now, we always put a parenthesis on the infinities. Now, on the 6, yeah, since it's used in both shadings, I'm putting a bracket. So, the overlap between the 2 solutions is from 6 to infinity. That is why, even though they didn't say it, you should literally graph the 2 answers so you can see, in this case, where the intersection is, where the overlap occurs. Good? Okay, let's look at problem number 2. Again, they've given me 2 inequalities to go solve, so let's go solve them. The first one, oh, you're going to divide both sides by that -7, aren't you? What does that mean? Is it still going to say x less than? Nope, you're right, it's going to flip. X is greater than or equal to -3. That's the first solution. Look at the second solution. Add the 20 to both sides, so I get x is less than or equal to 5. Good? Okay. Now remember, they want me to write the answer in interval notation, but interval notation is best written from a graph. So even though they didn't say to graph, we should graph, especially for us visual people. So I only care about the -3 and the +5 on this number line. So let's look at the first solution. The first solution says x is greater than or equal to -3. So which side of the negative 3 are we on? Good, we're to the right, all the way out to infinity. And on the negative 3, you're going to put a bracket because it says equal to. The second solution is x less than or equal to 5. So which side of the 5 are we on? Good, to the left of the 5. So I want all these numbers on this way, all the way up to negative infinity. And on the 5, also a bracket because it says equals. So we solved both inequalities, didn't we? But we haven't looked at the word and yet. What does and mean? Intersection. So when I'm looking at my graph, I'm looking for where these two shadings overlap each other, where they intersect each other, aren't I? So where do they overlap each other? Yeah, right here between negative 3 and 5, and there's brackets on both of them. Cool? Okay, hang in there. Got a couple more examples for us. Okay, let's look at problem number 3. Again, they've given us two inequalities to go solve, so we're going to solve those first. So I have negative 2x is less than or equal to negative 4. What do you have to do? Good, divide both sides by that negative 2, which means I end up with x is, hey, greater than or equal to a positive 2. Excellent, you remembered to flip the inequality. Good job. The next one, good, I have to move the 20 to the other side. So I end up with 5x greater than or equal to 25, and then divide both sides by a positive 5, which means x is greater than or equal to 5. Excellent. So now what? Yeah, graph, because if they want the answer in interval notation, I'm going to need to graph it. So when I graph it, there's only two numbers I care about on this number line, the 2 and the 5. So when I graph the first solution, x is greater than or equal to 2, a bracket on the 2 and everything to the right all the way out to infinity. Do you agree? Good. When I graph the second solution, I'm looking at all the numbers to the right of the 5, and the 5 is also going to get a bracket all the way to infinity, isn't it? Now, we took care of solving the two inequalities, but we still have to look at the word or. What's the word or refer to? Good, that's the union. And in math, union means it wants everything, all the shading. So when I look at this number line, I don't care just about the intersection. I want all the shading, because that's what union means. It wants where everything is shaded. So when I read from the left, the first number that's shaded is the 2. And the shading continues all the way out to infinity with a bracket on the 2. So in this case, the union of these two solutions starts at 2 and goes all the way to infinity. Are you with me? Excellent. Okay, number 4, I'm going to make a slight little change here. It's okay, you can handle it. All right, so again, first things first, we're going to solve this inequality. First inequality says x is less than negative 9. Agreed? We're going to solve the second inequality. And again, I'm going to make just a little change, adjustment. You can handle it. And this says, when I solve this second one, I am going to divide both sides by a positive 4. That doesn't change anything, right? So I have x greater than or equal to negative 3, don't I? Good. And then what do we need to do? Yes, we need to graph it. Even though they didn't say graph it, we should graph it because it's easier to write the interval notation. So here's my graph. Two numbers I care about, negative 9 and negative 3. And remember, that number line, you better put those numbers in the correct order. If you don't, it's going to mess everything up. Okay, so the first one. Yeah, I'm looking at all the numbers to the left of the negative 9, all the way out to negative infinity. Is x equal to negative 9? Nope, so we're going to put that parenthesis. Got it? Good. The second one, x is greater than or equal to negative 3. Yeah, so I want all the numbers to the right of the negative 3 all the way out to infinity. And that's right. In this case, I'm going to put a bracket. Now, same thing. We solved the two inequalities, but we still have to look at the conjunction. The conjunction means union, which means it wants all the shading, right? All the shading. Well, if I take a look at my number line, my shading actually starts at negative infinity and it stops at -9, doesn't it? But then it picks up again at -3 and ends at positive infinity, doesn't it? Okay, so we know in parentheses around our infinities. What about the -9? Good, a parenthesis. What about the -3? Excellent, a bracket. Now here's the deal. You have two interval notations for this one problem. I need this interval notation to be written as one, not two individual. So here's how we do it. I need to join these by a conjunction. And the conjunction I'm going to use is the word or. Because if I notice, the numbers that are in this interval are not the same numbers as in this interval. They're not the same. They're different. Are you with me? So, since this was an or problem or a union problem, then I am going to connect these two by the conjunction or, and the symbol I use is the union symbol. So my x's are in this interval or this interval. Got it? Okay, hang in there. Got a couple more problems for us. Okay, so let's look at problem number 5. Now, interesting, isn't it? Because I have two inequalities in here, don't I? I don't just have two sides of a problem. I literally have three sides of a problem, don't I? Okay, no big deal. Let's stay focused. What are we solving for? We're solving for x. So, what's the first thing I need to get rid of that's attached to this x? Yeah, I need to get rid of that -5, don't I? So, what are you going to do? Yes, you're going to add 5, aren't you? But you're not just going to add it to the middle. Math is balanced. If you add it to the middle, you've got to add it to the left as well as the right side. In this case, you've got three sides to work with, so to speak. But I'm going to stay focused. I need the x by itself, so I'm going to focus on getting the x in the middle by itself. Got it? Okay, so now, -2 plus 5, 3, less than or equal to 3x, because these drop out, less than 12. Excellent. Okay, is the x by itself yet? Not quite yet. What are we going to have to do? Good, I'm going to have to divide the middle by 3 so I can get the x by itself. But if you do it to the middle, excellent. You've got to do it to the left as well as the right, which means I have 1 is less than or equal to x, which is less than 4. Cool? Okay, now you know we've graphed those before. That's that sandwich, isn't it? So let's get the number line written down, or drawn I should say, and I care about the numbers 1 and 4, and the x's that I'm looking for are sandwiched between the 1 and the 4, aren't they? So that means I want every number in between here. What are you going to put on the 1? A bracket, because x is greater than or equal to the 1. What are you going to put on the 4? A parenthesis, because x is less than 4. So what's my interval notation look like? Good, the shading starts at the 1 that has a bracket on it. It ends at a 4 that has a parenthesis on it. These are the numbers that are a solution to this inequality. Cool? Awesome. Okay, let's look at number 6 over here. Again, same thing. I've got a sandwich going on, right? And I need to solve for x. Agreed? Okay, but do you notice I got a denominator? What are you going to do? You going to keep that denominator? Nope, we're going to get rid of it. So how do you get rid of that 4 there? Yeah, I have to multiply the middle by 4 over 1 so it cancels. Agree? But if you do it to the middle, good, you've got to do it to the left as well as the right. So Let's see what the problem really looks like. I've got negative 20 less than negative 3x plus 1 less than 8. Good? Okay. And now? Yeah, now I need to get rid of the 1. How do I get rid of that 1? I minus it from all three sides, which my next line looks like negative 21 less than negative 3x. These 1's drop out, less than 7. Okay, x by itself yet? Nope, I got to divide by negative 3, all three sides. Okay, so just watch for a second, okay? So negative 21 divided by negative 3, good, positive 7. In the middle I just have x, and over here I have a negative 7/3, don't I? Now here's why I asked you just to watch a second, because I divided by a negative number. So do these inequalities remain in the direction they're facing right now? No, they got to flip. So this one has to flip, and this one has to flip. And now let's look at this. X is less than 7, isn't it? X is also greater than negative 7/3. Agreed? Which of these numbers is smaller, the 7 or the negative 7/3? Good, the negative 7/3. So we should technically write the smaller number first. Why? Because it's going to mirror our number line. And on the number line, you write the smaller numbers on the left and the larger numbers on the right. Got it? Okay. So I know negative 7/3 is less than x. Correct? And x is also less than that 7, isn't it? Now this makes more sense in terms of how it's written. This looks proper to our brains especially. Okay, time to graph it because they want an interval notation. And gratefully, this is also another sandwich, isn't it? So we've got negative 7/3. We've got the positive 7. The x is in the middle of them, which means the numbers I'm looking for are in the middle of them. And since there's no equal to sign on either one, we get to put those parentheses, don't we? Which means my interval solution is the parenthesis negative 7/3 to positive 7 with a parenthesis. Cool? Okay, got it. Loving it. All right. You guys have fun with this stuff, and I'll catch you on the flip side.